Hello, everybody. Uh, my name is Oliver, and in the next half an hour, I'm going to talk about Threaddump analysis and using a particular tool that can make your life hopefully easier. Before we get to any specifics, I would like to walk you through the essentials to make sure that we are all on the same page and we can build on that. What is Threaddump and what exactly I'm going to talk about here? With JVM multi-threading, there are several ways how to inspect what's going on and how to debug, and Threaddump seems to be the single most essential one. It's a textual report that collects all the threads, its states, stack traces, monitors, etc. So it's a textual report with all this information. And this is an anatomy of a single thread like this. Over here in the blue color, it's the name of the thread. The purpose is purely informative. It's specified by the application itself. The yellow part are the thread attributes, not really important at this point. The red part is the state of the thread itself. It can be runnable, meaning that it's either running or it's waiting for a CPU where it can run. It can be blocked, meaning that it's trying to enter a synchronized block or a synchronized function / method, so it cannot proceed because somebody else is probably holding the monitor. It can be sleeping, and there are a couple of other states, but they are not used very frequently. So this is an important information. The white part is the stack trace of the thread itself. And the green part is another important thing. Those are the logs that are somehow involved in the monitor. The one that is usually reported on the very first stack frame is the thread that the thread is blocked on. So the thread is trying to enter a monitor, enter a synchronized section, and this is the monitor is trying to acquire. The second line, the logged, meaning that at this point, at this stack frame, object table, unexplored object, the thread has entered a synchronized section on that particular monitor. And the third one, at the very bottom, is the ownable synchronizer. It's not a monitor, it's a log, it's a different thing. You can see it is actually a Java util concurrent reentrant log, and these ownable synchronizers are logs that I acquired using lock and unlock methods. And those are reported separately. So this is how the thread looks like. What problem I'm going to talk about is today. Me and my team are taking care of a rather large deployment, and we tend to investigate quite large thread dumps. And this is a particular incident that happened, and we usually have thread dumps up to 2,000 threads in it. And using without any automation, it's really a waste of time to even try to find out something in there. You can see that in this case, it was 1,700 threads in there, quite a lot of lines of code. And this particular case, all the UI threads was stopped. When we looked into that, we find out that there is a lot of monitors, and over 300 of threads are simply blocked and cannot proceed. And obviously, as it usually is, there was only single thread to blame. And this is, let's look at how we can get there, how we can identify the single thread for you as a developer or an operator to point you to the real culprit. So at this point, you're clearly asking, well, there definitely has to be a tool for that, right? And there are many tools for that. But most of them share several attributes. One of them is that they are usually UI-based, which have a couple of disadvantages. Consider that you're investigating something that's happening on a production, and all you've got is a SSH access, or is a build machine, or you have just attached a Docker container. You cannot really use the tool there. So what you can do is take the jstack output, the Threaddump, move it to your workstation, and investigate it using the UI tool on your own computer. But it's sort of a distraction from what you want to do. You would like to investigate what's going on, and you need to switch to doing something else. This is a bit of a disadvantage. Another problem with this tool is that it's very hard to automate what you do somehow. Consider there is a particular problem, and the tool is capable of discovering it. That's great, right? But you sort of need to open it, then load the data, and then click through this, and at some point it tells you what the problem is. But you cannot really automate it. You cannot really make an automated check to verify if all 10 VMs is OK. You need to do it manually. And it doesn't really scale, and nobody really even tried that. So this is sort of problematic. So we would like to have something that can be automated. Is there a deadlock in JVM? Yes or no? Is this is there a thread that is executing this method, or it's stuck in a native code? Yes or no. And this is a question most of the UI-based tools is not able to answer. Another thing is that these tools are very convenient, which is great, and provides you a series of, let's say, reports or different kind of information. And that is all great. But the problem is that, well, as long as the functionality answers your question, you're fine. But if it doesn't, well, the tool is practically useless for you, because there's rarely any chance to slightly modify what it tells you, or to create a completely different report. So this is why we would like to have something that if you don't like what it provides, you can extend it. You can write your own report. You can take the report and rearrange it a bit so it's relevant for you, for your application, or for a particular problem. So what is this Dumpling? What it's trying to provide? It's a tool, and all you need is a terminal. You don't need any UI, you can use it, you can take it anywhere with you. Without any installation, you don't need to be a super user, you just download a simple file and it will work. That's nice. Aside from being user-friendly, we're trying to have something that's automation-friendly, but we'll still keep in mind that it's mostly users who's going to use it. And we're not only rely on the convenience as most of the tool, but even the power. So we're trying to provide a full spectrum, not only convenient, but powerful, so you can actually change. If your problem is covered with a standard report, that's all you need to use. You don't even need to understand the rest. But if it doesn't, you can always dig deeper and go as deep as you need to investigate the problem you've got. How? Right now, there's no installer, so what you got to do is just download a file, make it executable, run it. On the background, it will download a fat jar, place in the local directory, and that's it. You're all set. So you just run help, and you can start digging. And this is how you will proceed. You will just talk to the shell wrapper, then run some commands, and provide a source. You're about to investigate the data, you need to provide a source from somewhere. Dumpling have several factories where you can use them to get the data. So you can parse the Threaddump. You run jstack, place it into a file, and then you can have Dumpling to parse it and analyze the content. Another option is to connect to a JVM over JMX connections. So we just provide the host name, port, etc., and you will connect to a living JVM. Another option is use the jstack invocation wrapper. So you just provide a PID, and it will invoke jstack for you and load the data into Dumpling, so you can proceed with investigation this way. All these factories will create a model that hold all the information that are in the runtime, either of the running JVM or the data from the Threaddump. Then you can invoke some queries on that. Deadlock, every tool needs to have it, so you can run the query and it will give you a textual report if there are any deadlocks, what they consist of, etc. Blocking tree is my personally favorite. If you look at the Threaddump, it consists of thread, and they have some logs. Those are really low-level abstractions. When it comes to blockage, what's helpful is have a higher level abstraction over that. Consider that you have a thread you are interested in, and it doesn't run because it's blocked, trying to get a monitor or a log or whatever. So, okay, you identify that in a Threaddump, and you find out what log is trying to acquire. Okay, then you find the other thread that is holding it at the point, and you hope that you really discover the problem. But a thread can be blocked as well. So you need to do this over and over as long as you find it. Hopefully not many times in a row. What is more useful than thinking about threads and monitors is thinking about relationships between threads. I mean, there's some exclusive resource like monitor, and one thread is holding, and then we can actually say that the thread is blocking all the threads that are waiting on that monitor. And it's a useful abstraction to build on. This is exactly what's happening here. Here we got some 7 threads in the background. Nothing really looks suspicious from that. There are some logs, somebody's waiting on someone, but it's not really clear. What blocking tree does is basically organizing all threads based on these blocking-blocked relationship into a tree-like structures. So if you look over here, we see that thread A is actually not blocked by anybody else, but is blocking two threads, AA and AB. Thread AB is not blocking any other threads, but it's itself blocked by A. And thread AAA is transitively blocked by A. Threads B and BA are again blocked, but they are completely detached from the A's. So this is a way how you can get a high-level overview of what's going on when it comes to monitor or synchronizer blockage. It's very useful. Personally, every time I investigate some problem, I start with this one, and clearly points out if it is related to any blockage or not, and if it is, it very usually points right to the problem. So there's some textual summary of that, and as you can see, you can run it from the console just like this. So this is very convenient for you as a user. When you would like to use it from the automation, the command itself has a return code that represents a number of threads that is actually involved in the blockage. So you can say if you can make any decision, you can put it into your automation if you would like to, and make any decision based on that. Also, the query, like many others, accepts an option called show stack traces, which will actually show stack traces of the threads, only the threads that are involved. So if your problem is related to the blockage, you will not only see the hierarchy or the relationships between them, but the whole thread dump will be narrowed to the threads that are actually involved in the problem, and all of them will be hidden from you. So we'll be looking at what is relevant for you. Which brings us to another query, is the deadlock detection. Again, you see a rather convenient report, one deadlock, two threads involved, couple of monitors acquired, and the monitors that are actually part of the loop and they are cause of the deadlock are highlighted. So again, general report for you to know what's going on. If you provide a show stack traces option, you will actually see what these threads are doing, what the problem is. And the return value is the number of deadlocks detected. So you can clearly say, yes, no, is there a deadlock or not? So those are very convenient tools when there is a particular problem to investigate. But quite often it happens that none of it really answers your question. So at this point, you would like to get deeper and be able to create your own. I mean, when you have a thread dump with dozens or even hundreds of threads, it's not really easy to do any other way. So consider you would like to create something your own. Typically just filtering the threads based on a criteria. Show me all the threads that are blocked. Show me the threads that are investigating code from this class, or they are running these methods, or they have acquired a monitor of this class. There's many criteria you can possibly use, and it would be insane trying to implement some filter. So what we do instead is we take the runtime and expose it as a model to users for scripting. So what the grep command actually does is it accepts a predicate, which is a piece of a groovy expression, and it's used for filtering, and only the threads that match are reported. So you can come up with any predicate you like, provide it over here, and this is an example. So using this, you can filter only the threads that are either blocked or waiting. Obviously, you can come up with whatever you want, and you have access to the thread instance, which is a dumpling abstraction that represents a single thread. You have access to the whole header, to the name, stack traces, and logs and state, and you can create whatever condition you like. So this is very useful when you would like to narrow down the set and look only on the problematic parts. If this is still not enough for whatever reason, you can let's say that the blocking tree doesn't reveal the problem you have. Either it's not sufficient or it's a completely different kind of problem. You might want to create your own query. Well, now why? Consider that there is a known problem or limitation in your application, and you are getting confused reports. Every user worded slightly differently. So you have a problem to verify whether these user bug reports are actually about the known problem or not. Consider that you can provide user a rather short script that will be able to decide if this is the known problem or not, or the limitation. And the user can easily find out whether this is the problem, and they can apply the workaround you provide, or this is something new and it should be reported. Or you can give you, again, another script that will just give you a relevant information about what's happening in your application, because you're the author. You understand the application better than them, so you can get a narrowed report of what's going on. So you can provide such script either as a piece of text on a console or as a file, and you can create your own report, your own return code, your own structured textual report, everything you can. This is a simple DSL that is available for your scripts. You can access the runtime you have provided, and if you haven't, you can actually load it from any source. You can load it from the JMX, Threaddump, the process, much as exactly the same way as you would load it from the console. Actually, you can make it even more powerful if you provide some arguments. You can really create a script to detect the problem on production, run it periodically, and mail the administrator in case there is a problem. So this is how the scripting works. This DSL represented here basically gives you access to the Dumpling data model, and then you can use it to create any kind of criteria and arrange the data into any kind of report you like. In order to understand the data model, there is Javadoc sources. There is even a tutorial online, so you will need to start there. The whole data model basically consists of 3 different classes. Runtime, that basically holds the collection of threads, the thread itself that represents the data in a thread, and a thread set. The thread set is a set of all the threads in your application. And you can use that thread set to narrow down into based on specific condition. As you can see, you can filter it based on a predicate. So to only threads that are blocked. So you will get the condensed report, and you will work from there. The thread set can work with Java 6 as well as Java 8. I mean, with Java 7 and older, it also supports lambdas, and you can use all the capabilities of the Groovy to create your own report. So this is the DSL. It happened to us several times. For instance, we provide a Dumpling plugin for Jenkins, and Jenkins have the plugin have a wiki page, and there are several snippets of scripts to investigate the common problems. So you can give this to users or administrators of some local Jenkins instances and instruct them, when there is a problem, run this script, and you will find out what the problem is. So we walk through this. There's a couple of factories that are able to provide the model. The model is unified. It doesn't really matter whether the model is from parse Threaddump, from the running JVM, or any other kind. The queries simply don't care. The model is written in a way that it's convenient to use from scripts, so it's hopefully pleasant to work with, so you can investigate the problem without destruction, so to speak. At the top of that model and the DSL, there are the queries, the blocking tree query, the deadlocks query, and there are a couple of others. All of these is available to you from the Groovy script. So if you, for whatever reason, don't like how the deadlock query works, you can invoke it from Groovy, take the result, and you can make any other decision based on any attribute. Or you can just decorate it and make it different so it is relevant for what you do or relevant for your application. If you would like to use Dumpling differently than that, all of these is part of a Dumpling core model. It's released on Maven Central, so you can actually take Dumpling and put it as a dependency into either your test suite or your application, so you can investigate what the tests are doing, or you can use it for verification whether the series of operations you have performed actually created the thread state you expect. Or in case your test fail, you can actually capture a Threaddump for letter analysis to precisely understand what was the threading state at the time it failed. There is a thin layer above that for the Groovy scripting. If you, for whatever reason, would like to build a Groovy interpreter into your application that will have access to Dumpling, it proves us to be very useful. And all of that is wrapped into a fed jar we have used for the Dumpling CLI. There is no reason for you to depend on this as a Maven dependency. Now, why would you bundle a Dumpling into your own application? I wonder how many of you have already seen a message like this. JStack can fail I mean, consider that you are running a Java application and you would like to observe what's going on. There are several ways, and JStack tends to be the most popular because it's pre-installed with JDK, that's fine, and you don't need to do anything special for it to work. That's all great. There are other alternatives like debugging API, which you often need to enable first. The same goes for JMX. You need to think ahead so you are able to investigate. And the same happens in building something like bundling something like this into your application. The problem is that JStack may stop to work for an unpredictable amount of time. So if you don't enable any of these other methods, it can happen that you are running a system and you are not able to investigate what is going on. So this can happen basically in two different situations. One of them is easily fixable. You are not invoking JStack as the same user that's running the JVM. That's trivial. You just switch to the right user and it will start to work. Another problem is that one of the threads may not be able to reach a save point in a reasonable time, which means that JStack or the JVM is not able to infer correct stack traces of the threads, and it doesn't provide you the output. So you don't know. This can be a temporary situation. Some of the threads is just busy and it's not reaching any save point. So you retry a couple of times, try it after a minute, and you get the data. But it might not happen. Personally, I have seen a thread stuck for a couple of weeks in some kernel call, and it never recovered. And the JVM, I mean, some particular aspect of the application stopped working. Users were affected, and this was everything that JStack was willing to tell us, which is a problem because we cannot investigate what the problem is, and the problem cannot be fixed. So, best thing we can do is restart. But we will never understood what the real problem is. And at that point, it was great that we have Dumpling bundled, or basically any other way how you can get the Threaddump if the JStack stops working. Because without that, we would never understood what the real problem was. So this is what it is, and this is why we find it useful. It's a project hosted on GitHub, MIT licensed, it's still being worked on, and there are several things we plan to do, we plan to improve. One of them are native packages, so you don't have to download it on your file system or something like that. It would be much better if you can install it and then don't care about where you exactly placed it. Support for more virtual machine vendors. Right now, Dumpling supports Java 6 and above. We are not really established on Java 9. But the problem are several vendors like IBM and JRocket that tends to be different. Their Threaddump format is different. The Threaddump is obtained differently, etc. So that's where the support is not yet implemented. What we would like to do is to completely encapsulate all this. So you can just instruct Dumpling to talk to a JVM based on the PID, and it will figure out, without even caring if the Threaddump is in the IBM format or hotspot format or any other. So this is what it do, this is what we plan, and if you are interested, I would really love to hear from you what you believe it should do to make your life easier. We've got 5 more minutes, so if there are any questions or anything you would like to. Okay. Well, thank you everybody for coming.